Welcome to my channel, Chemistry Class. Good morning, everyone. Welcome back to Chemistry Class. My dear student, I hope you are doing well. And today we are going to study dipole-dipole interaction, which are an important type of intermolecular force. My dear student, these forces explain the attraction between polar molecules. So let's go step by step. Definition of dipole-dipole interaction. What is doing? Dipole-dipole interactions are attractive forces between the positive end of one polar molecule and the negative end of another polar molecule. My dear student, these interactions occur only in polar molecules, like molecules having permanent dipole moment. So, explanation of dipole-dipole interaction. My dear student, a polar molecule has two poles due to unequal sharing of electrons in a covalent bond. One end becomes slightly positive and the other end becomes slightly negative. When many such molecules comes close, the opposite pole attract each other. Example of dipole-dipole interaction. The first one is hydrogen chloride, HCl. HCl is a polar molecules because chlorine is more electronegative than hydrogen. So hydrogen becomes partial positive and chlorine become partial negative. The partial positive hydrogen of one HCl molecule is attracted to the partial negative chlorine of another HCl molecule. This is a dipole-dipole interaction in HCl and hydrogen chloride. The second example is acetone. The oxygen atom is highly electronegative, so it carries partial negative charge. The carbon attached to oxygen is partial positive. Thus, dipole-dipole attraction occurs between the partial positive carbon of one molecule and partial negative oxygen of another. This is a dipole-dipole interaction. An acetone. Now, characteristics of dipole-dipole interaction. My dear student, dipole-dipole interaction stronger than London dispersion forces but weaker than hydrogen bonds. Strength of dipole-dipole interaction depends on magnitude of dipole moment, and the second one is distance between molecules. The third one is responsible for higher boiling points of polar compounds compared to non-polar compounds of similar molecular mass. Importance of dipole-dipole interaction. My dear student, dipole-dipole forces explain why substances like HCl and C3Cl acetone have higher boiling points than expected. They also affect solubility. Polar dissolve in polar. For example, acetone dissolve in water due to dipole-dipole attraction. So, during dipole-dipole interaction are a key type of intermolecular force that keep polar molecules together. They are not as strong as hydrogen bonds, but still strong enough to affect the boiling point, melting point, and solubility of compounds. So this is all about today's lecture on dipole-dipole interaction. I hope you understand. Dear student, if this lecture help you, then don't forget to like the video, subscribe to the channel for more chemistry lectures, and share it with your friends, and comments your question below. Take care and see you in the next class. Thank you for listening.